Hello there, and welcome to the Sleeping Physicist. If you're someone who likes to unwind by thinking about stars, matter, and the quiet structure beneath reality, you're very much in the right place. Tonight, we'll let our attention drift gently into real physics and real discoveries. Some of what you'll hear may sound surprising, but all of it is grounded in how the universe actually behaves. And if you enjoy these slow, careful explorations, you're always welcome to like and subscribe. But for now, get comfortable, let your body rest, let your thoughts loosen their grip, and let's begin. What is reality made of according to quantum physics? Take a moment to notice where you are and how little effort it takes to feel supported. A surface holds your body, space remains open around you, and the room keeps its shape without needing attention or adjustment. Nothing feels uncertain or fragile because the world is already doing what it reliably does. Your body feels solid as it rests, weight meeting support in a way that does not need explanation. Objects remain where they are unless something intervenes, and the environment behaves the same from one moment to the next. This steadiness does not flicker or hesitate, which is why it so easily fades into the background of awareness. Physics begins here, not by rejecting this experience, but by accepting it as real and consistent. The issue is not whether solidity exists, but how such dependable structure can arise at all and continue without exception. When you place your hand on a table, it does not pass through, and the interaction ends exactly where it should. Pressure appears, motion stops, and support is provided without effort or surprise. At this scale, reality behaves exactly as it presents itself. That reliability matters because it is not imagined or assumed. Objects persist through time. Space feels continuous rather than broken. Causes lead to effects without delay. These outcomes define the world you trust every day. If you are listening while lying down or sitting quietly, you may notice how complete that trust already is. You do not test the floor before shifting your weight, and you do not question whether the chair will remain a chair. Confidence like this is built from countless interactions that have never failed. At human scales, reality appears smooth and stable, with objects that feel whole and space that behaves predictably. Whatever reality is made of at its deepest level must be capable of producing this steady surface without exception, because this dependable structure is what the universe delivers to us every single day. That dependable surface carries an assumption so familiar it rarely comes into focus. Solidity feels like a property objects simply possess, as though matter is made from tiny pieces that are themselves solid and tightly packed together. The table holds, the floor supports, the wall blocks movement. From this, it feels natural to imagine reality as built from small, hard constituents stacked side by side. This picture fits comfortably with everyday experience. When you press on something, it resists. When you drop an object, it falls and lands with weight. When two things collide, they do not pass through one another. Each interaction reinforces the sense that matter is composed of little bits of substance, each one solid in the same way the whole appears to be. Because this assumption works so well at human scales, it rarely demands attention. It explains why objects keep their shape and why boundaries feel firm. It allows the mind to rest, because it offers a simple answer that does not require further inspection. Matter feels solid because it is made of solid pieces. Physics notices this assumption not because it is foolish, but because it is powerful. Any idea that explains so much so easily becomes a foundation, and foundations are worth examining carefully. The question is not whether this picture is useful, but whether it is accurate all the way down. When you imagine cutting an object in half, then cutting it again, and again, the intuition remains the same. Each piece is expected to retain its solidity, just smaller than before. Even at scales far beyond direct perception, The mind carries this expectation forward. Solidity is assumed to persist through every division. This expectation feels unavoidable because it mirrors how experience scales in daily life. A large object behaves like a collection of smaller ones. A pile of grains behaves like a mound. The rules appear to repeat themselves without change. From this, it seems reasonable to assume that reality is built from miniature versions of what we already know. Yet this picture rests on habit rather than evidence. It extends a familiar pattern into regions where direct experience no longer applies. Physics becomes interested precisely at that boundary, where intuition continues confidently, but measurement begins to speak more carefully. The assumption of solidity does important work, but it also hides a question. If matter truly is made of solid pieces, then those pieces must themselves occupy space in a definite way and exclude everything else completely. They must behave like tiny versions of tables and floors, scaled down without changing their nature. Once this assumption is stated clearly, it becomes something that can be tested rather than trusted. Physics does not abandon it immediately. It carries it forward into experiment and observation, where its limits can be revealed without argument. With that assumption made explicit, the path ahead tightens. Either solidity persists unchanged at smaller scales, or something more subtle replaces it. Determining which of those is true becomes the next necessary step. Once the assumption of solidity is placed under scrutiny, investigation moves inward. Physics begins to look beneath surfaces, not by imagination alone, but by probing matter with controlled experiments that reveal how it responds when examined more closely. What appears firm and continuous is asked to account for its own behavior under measurement. The first surprise comes from scale. When matter is examined beyond what the senses can resolve, it does not remain uniformly dense. Instead, structure appears. There are regions where influence is strong and regions where almost nothing seems to be present. The idea of matter as a filled block begins to loosen its grip. Atoms enter the picture here, not as philosophical concepts, but as experimentally inferred entities. They explain regular patterns in chemistry and predictable behavior in materials. At first, they seem to rescue the intuition of solidity by offering smaller building blocks beneath larger objects. Looking closer still changes that picture. Experiments reveal that atoms are not compact spheres. They are structured systems with a dense center and vast surrounding regions where no material substance is found. Compared to the size of the atom, its central core occupies almost no volume at all. This relationship is difficult to appreciate intuitively. If an atom were expanded to the size of a large room, its central core would be smaller than a grain of dust, suspended far from the walls. Everything else would be space. Yet this sparse arrangement produces the solidity you feel without exception. That result forces a shift in understanding. Solidity cannot come from matter being tightly packed in the ordinary sense. The space inside atoms is not filled with miniature substance, yet objects resist, support, and persist just as reliably as before. This does not weaken the reality of matter, it sharpens it. Whatever produces solidity does not require continuous material filling space. Instead, it must arise from how these sparse structures interact and constrain one another. At this stage, emptiness does not mean absence. The space within atoms is not inert or irrelevant. It is governed, structured, and active in ways that do not announce themselves to the senses. Effects appear without anything visible occupying the region where they occur. With this discovery, the classical picture breaks cleanly, but not destructively. Matter is no longer imagined as solid all the way down. It becomes something structured, extended, and mostly empty, yet capable of producing unwavering physical outcomes. This result does not leave understanding adrift. It narrows the possibilities. If solidity does not come from filled space, it must come from something else that operates across that space with consistency. Identifying what plays that role becomes the next unavoidable step. Once atoms are understood as mostly empty space, attention turns to what actually occupies that space and governs how atoms behave. The focus narrows naturally toward the components responsible for structure, stability, and interaction. Among these, one stands out immediately because it refuses to behave as intuition expects. Electrons enter the picture as essential participants in atomic structure. They are associated with the regions surrounding the atomic core and determine how atoms bond, repel, and arrange themselves. Without them, chemistry collapses and matter loses its familiar forms. At first glance, it is tempting to imagine electrons as tiny solid particles moving around inside atoms like miniature objects. That picture does not survive careful observation. When experiments attempt to track an electron's position, the result is not a clear path or a defined location. Instead, outcomes appear spread out, distributed across regions rather than pinned to a point. The electron does not behave like a small bead traveling through space. This behavior is not due to experimental clumsiness or missing information. It persists no matter how refined the measurement becomes. The more precisely position is constrained, the less predictable motion becomes. The electron resists being reduced to a solid object with a definite trajectory. What replaces that classical picture is not chaos, but structure of a different kind. The electron occupies space in a way that is extended rather than localized. Its presence is described by where it can influence outcomes, not by where it sits as an object. The atom's stability depends on this spread-out character, rather than being disrupted by it. This shift marks a decisive break. At this scale, the idea of a solid constituent no longer applies. The electron is real and effective, yet it does not resemble anything solid in the everyday sense. It cannot be assigned a shape or surface that defines a boundary in space. Despite this, electrons produce consistent results. Atoms form predictable patterns. Materials behave reliably. The loss of classical solidity does not remove order. It replaces one kind of structure with another that operates through constraint rather than contact. This realization tightens the story. If the components of matter are not solid pieces occupying space, then solidity must arise from how these components behave collectively. The focus shifts from objects themselves to the rules that govern their presence and influence. With electrons, the classical image of matter breaks for the first time in a way that cannot be repaired by refinement. Something fundamentally different is at work. Understanding what that difference is becomes the next necessary step forward. Once electrons refuse the role of solid objects, the description of their behavior must change. Observation no longer supports the image of something traveling along a definite path. Instead, experiments reveal patterns that spread, overlap, and interfere in ways that belong to waves rather than particles. This behavior appears most clearly when electrons are allowed to move freely and then encounter a constraint. Instead of arriving at a single predictable point, their effects distribute across space. Over many repetitions, a stable pattern emerges. The pattern is not random. It has shape, symmetry, and internal order. That order matches what waves produce. When waves pass through narrow openings or around obstacles, they spread out and form regions of reinforcement and cancellation. The same mathematical structure appears in the outcomes associated with electrons. Where reinforcement occurs, effects are likely. Where cancellation dominates, effects fade. This does not mean electrons turn into water waves or vibrations in air. The resemblance lies in behavior, not substance. The electron does not ripple through space as a material medium. What spreads is the influence it can exert and the way outcomes are distributed. At this scale, location becomes a matter of possibility rather than certainty. The electron is not found at a point until interaction forces a definite outcome. Before that, its presence is extended, shaped by constraints rather than motion along a path. This shift resolves a growing tension. If electrons were tiny solid objects, their spread-out effects would be impossible to explain. Wavelike behavior accounts for the observed patterns without adding unnecessary assumptions. Structure is preserved, even though classical imagery is abandoned. Crucially, this behavior is consistent. The same conditions produce the same distributions every time. Nothing about this description is vague or arbitrary. The patterns are reliable enough to be predicted with precision, even though individual outcomes cannot be assigned in advance. With this understanding, matter becomes something that behaves like a set of allowed patterns rather than a collection of solid pieces. Stability arises from repeated structure, not from rigid substance filling space. The world remains dependable because these patterns obey fixed rules. This realization deepens the departure from everyday intuition. Matter is no longer defined by where it is, but by how its influence is arranged. What? Something becomes inseparable from how it can act. Once wave-like behavior is established as fundamental, the path forward narrows again. A description based on possibilities and patterns is required. Developing that description becomes the next unavoidable step. Once wave-like behavior becomes unavoidable, description shifts again. Matter can no longer be treated as something that simply occupies space and moves through it. Instead, physics begins to describe what is allowed to happen, where outcomes can occur, and how likely each outcome is to appear. At this level, certainty gives way to structure of a different kind. An electron is not assigned a position in advance. What exists instead is a well-defined set of possibilities, each one weighted, shaped and constrained by the conditions around it. These possibilities are not guesses. They are calculated features of how the system behaves. This change does not introduce vagueness. It introduces precision of a new sort. The description specifies regions where outcomes are more likely and regions where they are strongly suppressed. Over many repetitions, these probabilities reveal themselves as stable patterns that do not drift or blur. The uncertainty lies only in individual events, not in the structure that governs them. Possibility here does not mean anything can happen. It means only certain outcomes are permitted, and they are permitted in specific ways. The rules are strict. They determine how probabilities spread through space and how they respond to boundaries, forces, and interactions. This can feel counterintuitive because everyday experience trains attention on single outcomes. A ball lands in one place. A sound comes from one direction. At quantum scales, physics describes the full range of what could occur before one outcome is realized. That description remains real and effective even before anything definite happens. When interaction occurs, one of these possibilities becomes actual. The system responds according to its constraints, and a specific result appears. After that, the description updates to reflect what has changed. The process is orderly and repeatable, not mysterious or arbitrary. This framework resolves earlier conflicts. The spread-out behavior of electrons no longer needs to be explained as motion through space. It is the expression of allowed possibilities shaped by the environment. Stability arises because these possibilities are governed by fixed rules that do not fluctuate. Importantly, this description applies universally. Every fundamental component of matter follows the same logic. What differs from system to system is not the rules themselves, but how those rules are applied through boundary conditions and interactions. With this shift, the idea of matter as substance recedes further. Reality begins to look less like a collection of things and more like a network of permitted behaviors. What exists is defined by what can happen and how reliably those outcomes appear. Once particles are understood as structured possibilities rather than solid objects, the foundation beneath them comes into focus. Something deeper must be supporting and organizing these possibilities. Identifying that foundation becomes the next necessary step. With particles understood as structured possibilities rather than solid pieces, attention settles on what gives those possibilities their shape. The patterns do not float freely. They are organized, constrained, and repeated with exact consistency. Something must exist that carries these rules everywhere, even where no particle is present. That role is played by quantum fields. A field is not an object and not a substance. It is a continuous physical presence that extends throughout space and time, setting the conditions for what can happen at every location. Where earlier intuition imagined empty space, physics finds fields already in place. Each type of particle corresponds to its own field. Electrons arise from the electron field. Other particles arise from their respective fields. A particle is not added to space from outside. It appears as a localized activity within a field that is already there, shaped by constraints the field enforces everywhere. This changes what made of means at a fundamental level. Matter is no longer primary. Fields come first. What we call particles are specific ways fields can behave when energy is present and conditions allow certain patterns to form. Fields do not switch on and off. They do not wait for matter to arrive. They exist continuously, even in regions where no particles are detected. Space itself is inseparable from these fields, because their presence defines what space can support and how it can respond. The reliability observed at larger scales now has a clear source. Fields obey fixed rules. Those rules determine which patterns are stable, which interactions occur, and which outcomes repeat without variation. Stability is enforced, everywhere at once, rather than assembled piece by piece. This picture also explains why different particles behave differently. Each field has its own constraints and allowable patterns. The diversity of matter arises not from different substances, but from different rule sets acting through different fields. Importantly, this framework restores order without returning to solidity. There is nothing hard or filled at the base of reality. There is structure instead, present everywhere and operating continuously. What exists is governed behavior, not material stuffing. By grounding particles in fields, physics reaches a stable foundation. Possibilities are no longer unsupported. They are expressions of underlying fields that define what can occur and how reliably it will do so. At the deepest level reached so far, reality is organized by fields that operate everywhere and always according to rule. With fields established as the underlying structure, space itself takes on a different character. What once appeared as an empty stage becomes an active participant. Even where no particles are present, fields remain, and their presence has measurable consequences. In everyday language, empty space suggests absence. It suggests nothing happening, nothing existing, and nothing exerting influence. Physics does not support that picture. Experiments show that regions cleared of particles still exhibit activity that cannot be removed or silenced. This activity does not appear as visible motion or material substance. It shows itself through effects. Energy levels shift. Forces register subtle changes. Systems behave differently than they would if space were truly empty. These outcomes occur reliably and repeatably. The reason is simple within the field framework. Fields cannot be switched off locally. They exist everywhere, and even in their lowest energy state, they retain structure. This baseline state is not inert. It sets limits, enforces constraints, and participates in interactions. Calling this empty space becomes a convenience rather than a description. Nothing visible occupies the region, yet physical rules are already in place and already acting. Space is quiet, but it is not blank. It is prepared. This preparedness matters. When particles appear, they do not enter a neutral void. They emerge within a structured environment that shapes how they behave from the first moment. Outcomes are guided not by collision with matter, but by the conditions already present. The persistence of these conditions explains why physical laws apply uniformly. No region of space behaves differently simply because it lacks particles. The same constraints operate everywhere, ensuring that behavior remains consistent across vast distances and times. This picture removes a lingering gap. If fields organize particles and fields exist everywhere, then there is no need for special mechanisms to transmit influence across emptiness. Space itself carries the rules, continuously. At this level, emptiness is redefined. It is not the absence of reality. It is the presence of structure without localized activity. What governs behavior is already there, even when nothing seems to be happening. By recognizing that empty space is physically active, the framework becomes complete at another level. Fields provide structure, space carries them everywhere, and behavior remains constrained without interruption. Reality does not thin out where matter disappears. It remains governed, continuous, and fully in place. With space understood as structured and active, energy finds its proper place. It no longer belongs primarily to objects moving through emptiness. It belongs to fields themselves and to the ways those fields can change. In everyday experience, energy is associated with motion, heat, or impact. Something moves faster, something grows warmer, something strikes and transfers effort. These are real effects, but they are surface expressions rather than the source. Beneath them, energy is already present as a feature of the fields involved. A field can be calm or excited. It can remain near its baseline state or support patterns that carry higher energy. These differences do not require objects to exist first. They are properties of the field's condition. When a particle appears, it is not bringing energy into the field from outside. It is a localized expression of energy already allowed by that field. This reframing resolves a quiet confusion. If particles arise from fields, then energy cannot be something particles own independently. It must be something fields distribute, store, and release according to rule. Motion, heat, and radiation become ways energy reorganizes itself within the field structure. This is why energy behaves consistently even when matter changes form. Energy can move from one pattern to another without disappearing. A particle can vanish and its energy reappear as radiation because both are field behaviors. Nothing needs to be carried across space by substance. The field already holds what is required. At this level, conservation takes on a clearer meaning. Energy is not conserved because objects faithfully pass it along. It is conserved because fields evolve according to strict constraints that do not allow arbitrary loss or creation. Change is permitted, violation is not. This understanding also explains why empty space has measurable energy effects. Even in the absence of particles, fields possess a baseline activity that cannot be reduced to zero. That baseline influences how systems behave and sets limits on what transformations are possible. By locating energy in fields rather than objects, physics arrives at a stable accounting. Every process becomes a redistribution within an existing structure, not a transaction between independent things. Predictability is preserved because the governing rules apply everywhere and always. At this point, matter, space, and energy are no longer separate ingredients. They are aspects of a single framework in which fields define what exists, how it can change, and how those changes remain constrained. Reality is not built from objects carrying energy through space. It is built from fields whose states determine everything that can occur. With fields and energy providing a stable foundation, the role of measurement becomes clearer. What turns possibility into a specific outcome is not attention or awareness. It is physical interaction governed by the same rules that apply everywhere else. In everyday language, measurement sounds passive. Something is observed, a reading is taken, information is recorded. At the quantum level, this framing breaks down. Nothing can be measured without interaction, and interaction always involves an exchange within fields. When a system interacts with its surroundings, conditions change, energy redistributes, patterns that were previously spread across many possibilities are forced into a particular arrangement. The outcome is not chosen arbitrarily. It follows directly from how the interaction constrains the system. This is why outcomes appear definite after measurement. The system is no longer isolated. It has become entangled with a larger environment that enforces consistency. What remains is not uncertainty, but a specific result stabilized by interaction. Importantly, no special role is played by a human observer. A detector, a screen, or any physical system capable of interaction produces the same effect. Measurement is not about looking, it is about coupling. Wherever coupling occurs, possibilities narrow into outcomes. This resolves a common confusion. The quantum description does not suggest that reality waits for someone to notice it. It shows that reality responds to interaction. Definiteness arises when systems can no longer evolve independently and must obey shared constraints. The same process operates constantly. Particles interact with fields. Fields interact with one another. Environments interact with systems. Outcomes become fixed because interaction removes alternatives, not because awareness intervenes. By understanding measurement this way, continuity is restored. The quantum world does not require a separate set of rules for observation. The same physical principles apply before, during, and after outcomes appear. Nothing discontinuous is introduced. At this stage, the picture stabilizes further. Possibilities are real. Outcomes are real. The transition between them is governed by interaction within fields. Reality does not flicker between states of being and not being. It evolves according to constraints that determine when and how specificity appears. With measurement grounded in interaction rather than observation, the framework remains coherent and complete. What becomes real does so because physical systems meet and constrain one another, and the result is a world that behaves consistently without exception. With interaction understood as the source of definiteness, a deeper regularity comes into view. Even as outcomes vary, certain features never do. No matter how complex the interaction, some quantities remain fixed, and some patterns are never violated. These invariants are not imposed afterward. They are present from the start. They act as constraints that limit what fields can do and how systems can evolve. Change is permitted only within these boundaries, which is why behavior remains orderly even when individual outcomes differ. In everyday terms, this appears as conservation. Energy does not vanish. Momentum does not appear without cause. Charge remains balanced. These are not habits nature tends to follow. They are strict requirements built into how fields operate. The importance of this becomes clear at the quantum level. Possibilities may spread and outcomes may differ from one event to the next, but conservation laws apply to every allowed outcome equally. The range of possibilities is shaped by what must remain unchanged. These constraints do not compete with uncertainty. They coexist with it. While the exact result of an interaction may not be predictable in advance, The set of results that are permitted is sharply defined. Nothing outside that set can occur. This is why the quantum description remains precise rather than permissive. It does not allow anything to happen. It allows only what respects the underlying constraints. Fields evolve freely within those limits and never beyond them. The presence of conservation laws also explains large-scale stability. Because constraints apply everywhere and at all times, patterns can persist and accumulate. Structures form. Systems endure. Predictability emerges naturally from rules that do not fluctuate. At this level, order no longer depends on solidity, locality, or determinism. It depends on constraint. What is conserved anchors behavior, even as details vary. The world holds together because certain features are protected against change. By recognizing conservation laws as expressions of deeper constraints on fields, physics secures its framework. Variability is allowed, freedom exists, but everything unfolds within boundaries that never loosen. Reality is governed not by chance, but by rules that remain fixed no matter how events unfold. With constraints established as the governing backbone, stability becomes explainable rather than assumed. Objects do not persist because they are made from hard substance. They persist because the rules acting on fields restrict how patterns can change. At small scales, fields allow only certain configurations to remain intact. When energy settles into one of these permitted arrangements, it does not drift freely. The configuration holds because departing from it would violate the constraints already in place. Stability appears as a consequence of what is allowed, not as a property added afterward. This is why atoms have characteristic sizes and shapes. Electrons do not collapse inward or wander off arbitrarily. The field patterns that define atomic structure occupy specific forms that satisfy all governing rules simultaneously. Deviations are suppressed because they are not permitted outcomes. The same logic scales upward. Molecules form because particular arrangements minimize conflict between constraints. Solids retain shape because the collective patterns of their fields reinforce one another. Rigidity is not imposed by forceful packing. It emerges from coordinated restriction. From the outside, this feels like firmness. From within the framework, it is balance. Each stable object represents a configuration that satisfies many constraints at once, leaving no room for spontaneous rearrangement. Change requires interaction because stability is already fully accounted for. This explains why properties repeat so reliably. An electron always behaves like an electron. An atom of a given type always exhibits the same responses. These consistencies are not habits. They are enforced by the structure of the fields themselves. Temperature, pressure, and material strength follow the same logic. As conditions vary, fields reorganize within permitted limits. When thresholds are crossed, new stable configurations appear. Phase changes occur not because rules break, but because different arrangements become allowed. Nothing in this process is approximate. Stability is exact wherever constraints are exact. Objects endure because their defining patterns are protected against drift by the same laws that govern everything else. At this point, solidity has been fully replaced. What remains is reliable structure enforced by rule. Objects feel solid because their underlying configurations are locked into place by constraints that do not relax. Stability is not an added feature of matter. It is the natural outcome of how reality is governed. With stability explained through constraint, the appearance of an everyday world follows naturally. Large objects do not require new laws layered on top of quantum behavior. They arise because many constrained patterns act together and reinforce one another. At small scales, possibilities spread. At larger scales, interactions multiply. Each interaction links a system to its surroundings, reducing the range of outcomes that remain available. As this linking accumulates, behavior becomes increasingly specific. Variability is not eliminated, but it is narrowed so tightly that only one outcome remains relevant. This process does not rely on averaging in a vague sense. It relies on scale. When enormous numbers of quantum events are constrained simultaneously, the combined result behaves predictably. The rules do not change, their effects compound. This is why classical behavior feels inevitable. A table does not flicker between shapes because the number of interactions stabilizing it is overwhelming. Every part of the system is continuously coupled to countless others. Alternatives are suppressed before they can matter. From this perspective, classical reality is not separate from the quantum world. It is the quantum world operating under conditions of extreme constraint. The same principles apply, but the range of allowed behavior becomes so narrow that uncertainty no longer appears. This explains why everyday physics works so well. Approximations succeed because they sit on top of deeper rules that already enforce stability. Classical descriptions capture what remains after quantum variability has been constrained out of relevance. Importantly, nothing new needs to be added. No boundary exists where quantum rules stop and classical rules begin. There is only a smooth transition driven by scale, interaction, and constraint. The appearance of solidity is the macroscopic expression of microscopic governance. This continuity preserves coherence. The universe does not switch frameworks as systems grow larger. It applies the same rules, everywhere, allowing complexity to emerge through accumulation rather than exception. At this stage, the puzzle dissolves. The everyday world is not an illusion layered over quantum reality. It is the most constrained expression of it. Classical behavior is what quantum rules look like when alternatives are no longer available and predictability becomes complete. With classical behavior understood as the result of extreme constraint, time regains a clear role. Events do not unfold randomly or out of order. They follow sequences enforced by the same rules that govern fields, interactions, and stability. At the quantum level, processes are not timeless. Changes occur, interactions happen, outcomes follow conditions. What differs from everyday experience is not the existence of causality, but how it is expressed. Instead of single, definite paths, multiple allowed developments coexist until interaction constrains them. Cause still precedes effect. An interaction must occur before an outcome can be fixed. Energy must redistribute before a system settles into a new configuration. These relationships are preserved exactly. What changes is that the path between cause and effect may include many permitted possibilities rather than one predetermined route. Time enters as the ordering of these changes. Fields evolve, configurations shift, interactions accumulate. At each step, constraints determine what transitions are allowed and which are forbidden. Nothing jumps ahead of the rules. Nothing resolves before the conditions are in place. This structure explains why time feels directional at larger scales. As interactions accumulate, systems become increasingly constrained. Alternatives disappear, records form, memory becomes possible. The past leaves stable traces while the future remains open only within limits. Direction emerges from accumulation, not from exception. Quantum descriptions respect this ordering fully. Even when outcomes cannot be predicted in advance, their sequence remains fixed. Preparation comes before interaction. Interaction comes before result. The framework does not permit effects without causes or reversals without conditions. At macroscopic scales, this ordering becomes rigid. The number of interactions enforcing it is enormous. Time feels smooth and irreversible because the constraints preventing reversal are overwhelming. What could happen narrows so completely that only one history remains consistent. This continuity removes a common misunderstanding. Quantum physics does not dissolve causality. It preserves it at a deeper level. Uncertainty applies to outcomes, not to order. The universe still unfolds step by step, with each state arising from the one before according to rule. By placing time and causality within the same constrained framework as fields and interactions, coherence is maintained. Events follow one another because they must. The flow of time is not imposed from outside reality. It is the natural ordering of change governed by constraints that never loosen. At this point, another feature becomes unavoidable. Everything described so far depends not only on fields and energy, but on how states are distinguished from one another. What can happen is defined by what is different, what is constrained, and what is preserved. That structure is captured most cleanly by information. Information here does not mean messages or symbols. It refers to the physical distinction between possible states of a system. A system that can be in one state rather than another carries information by virtue of that difference alone. Fields encode which configurations are allowed and which are not, and that encoding is physical. This perspective clarifies why change is never arbitrary. When a system evolves, information is not created from nothing. It is rearranged. Interactions redistribute information across larger systems, binding parts together so that they can no longer be described independently. Outcomes are specific because information has been constrained into a particular form. At the quantum level, information cannot be copied freely or erased without consequence. These limits are not technological, they are fundamental. They arise because fields and interactions preserve certain distinctions while forbidding others. What can be known, recorded, or transferred is governed by the same constraints that govern energy and stability. This explains why measurement has lasting effects. When an interaction fixes an outcome, information about that outcome becomes embedded in the environment. Traces remain, correlations spread, reversal becomes impossible without undoing an enormous web of linked distinctions. The result feels permanent because it is physically distributed. Information also provides a unifying description across scales. At small scales, it appears as constraints on quantum states. At large scales, it appears as records, memory, and structure. The difference is not in kind, but in how widely information has been shared and locked in. Seen this way, reality is not built from substance alone. It is built from allowed distinctions enforced by physical law. Fields define possible states. Constraints define which distinctions matter. Information is the bookkeeping that keeps track of what is allowed, what has occurred, and what cannot be undone. Nothing abstract has been added. Information is not layered on top of physics. It is already present wherever rules restrict outcomes. Without it, stability, causality, and measurement would have no footing. By recognizing information as fundamental, the framework gains closure. Reality consists of fields whose states carry energy, obey constraints, and encode distinctions that persist. What exists is not just what is there, but how it is allowed to differ. Information is the structure that makes those differences real and consequential. By the time information is recognized as physically real, separateness itself comes into question. Systems that interact do not always return to independence afterward. In many cases, they remain linked in a way that cannot be reduced to individual parts with their own complete descriptions. This linkage is called entanglement, and it is not a force or a signal. It is a structural condition. When two systems interact under certain constraints, the information describing one becomes inseparable from the information describing the other. What exists afterward is a single combined state, even when the systems move far apart. In ordinary experience, distance usually means independence. Objects separate, influences fade, and behavior becomes local. Entanglement does not follow that pattern. Separation in space does not restore separateness in description. The systems carry shared constraints that continue to govern outcomes wherever they are. This does not permit uncontrolled influence or faster-than-light communication. Nothing is sent from one system to the other. What changes is how outcomes are defined. Each system no longer possesses its own independent set of possibilities. The allowed outcomes belong to the pair as a whole. Because of this, results that appear random when viewed alone become correlated when compared. The structure was already present. Measurement does not create the connection. It reveals a relationship that was enforced by the prior interaction and preserved by constraint. Entanglement follows directly from the framework already built. Fields allow interactions. Interactions redistribute information. Constraints prevent that information from being freely separated again. The result is a state that must be treated as unified, even when its components are distant. This unity does not disrupt stability. It refines it. Systems behave reliably because the shared structure restricts what can happen. Correlations are not coincidences, they are enforced by the same rules that govern conservation, interaction, and measurement. At larger scales, entanglement is usually dispersed into the environment. Interactions multiply. Shared information spreads so widely that it becomes inaccessible. Classical independence reappears, not because entanglement vanishes, but because it is no longer confined to a small system. Seen clearly, entanglement removes the last trace of substance-based thinking. Reality is not built from independent pieces that merely affect one another. It is built from structured relationships that can bind systems into unified wholes. With this in place, the picture gains depth without losing coherence. Fields provide the medium. Information provides distinction. Constraints preserve structure. Entanglement shows that what exists fundamentally is not isolated things, but organized relationships that remain real regardless of distance. With entanglement established as a real and persistent structure, the idea of a completely local world requires adjustment. Objects still appear separate. They occupy different places, they move independently. Yet this separateness now sits within a deeper framework that does not divide reality as cleanly as experience suggests. Local behavior remains intact because interactions are local. Systems influence one another through nearby contact within fields. No outcome appears without a physical process occurring where it happens. Everyday causality is preserved exactly as it is lived. What changes is the background against which locality operates. The rules that govern local events are not confined to local regions. They are global. Fields extend everywhere. Constraints apply universally. Information can be shared in ways that do not respect simple spatial division. Because of this, local objects are best understood as stable patterns within a broader, non-local structure. They behave independently because interactions with their surroundings continually reinforce that independence. When those interactions dominate, separateness becomes exact for all practical purposes. This explains why the world feels classical most of the time. Environmental interaction rapidly spreads information outward. Any delicate linkage between systems is diluted across countless degrees of freedom. What remains is a local object with well-defined properties and predictable behavior. Non-local structure does not interfere with this. It supports it. The same framework that allows entanglement also allows its dispersion. Independence is not assumed. It is produced by interaction at scale. Seen this way, locality is not fundamental, but it is real. It emerges wherever constraints isolate behavior effectively. Objects appear separate because the rules permit and enforce that separation under common conditions. This removes a false conflict. Quantum physics does not deny the reality of local objects. It explains why they exist and when they do not. Locality is conditional, not illusory. By placing local experience within a non-local foundation, the picture remains coherent. The world you touch is real. Its independence is real. Both are outcomes of deeper structure rather than primitive facts. At this stage, reality can be described consistently at every scale. Fields provide continuity. Constraints enforce order. Information binds or separates systems as interaction allows. Local objects exist because the framework makes them stable, even though the structure beneath them is not divided in the same way. With the framework now firmly in place, it becomes important to clarify its boundaries. Quantum physics is often burdened with interpretations it does not require and claims it does not make. Removing those additions strengthens the picture rather than weakening it. Quantum physics does not claim that reality is created by human thought. Outcomes do not depend on belief, attention, or awareness. Physical processes unfold whether or not anyone is present to witness them. Interaction, not observation, determines when possibilities become definite. It also does not claim that the universe is fundamentally chaotic. While individual outcomes may vary, the structure governing those outcomes is exact. Fields behave lawfully. Constraints hold without exception. Uncertainty applies within limits that are sharply enforced. Another common misunderstanding is that quantum physics replaces explanation with mystery. In practice, it does the opposite. It removes assumptions that no longer work and replaces them with mechanisms that can be tested and relied upon. Where classical pictures fail, quantum descriptions restore predictability at a deeper level. Quantum physics does not suggest that anything can happen. Possibility is not freedom without restriction. It is permission granted within strict boundaries. Many imagined outcomes are simply forbidden. The theory is selective, not permissive. It also does not deny reality to the everyday world. Tables, chairs, bodies, and planets are not illusions or approximations in a dismissive sense. They are stable outcomes produced by quantum rules operating under heavy constraint. Their reliability is explained, not questioned. Importantly, quantum physics does not abandon causality. Causes still precede effects. Interactions still lead to outcomes. What changes is how causes are represented before outcomes occur. The chain remains intact even when individual links are probabilistic. By stating clearly what quantum physics does not require, the picture sharpens. No hidden observers are needed. No mystical agency is invoked. No collapse of logic is accepted. The framework stands on physical structure alone. This clarification removes distraction. What remains is a theory grounded in fields, constraints, information, and interaction. Its claims are precise, limited, and sufficient. With misunderstanding set aside, the answer it offers can be stated cleanly. Reality is not unknowable, nor is it arbitrary. It is governed, structured, and consistent, and quantum physics describes that governance without excess or embellishment. At this point, the answer can be stated without qualification or retreat. Reality is not made of solid substance in the everyday sense. It is made of structured fields governed by constraints, whose states carry energy and information, and whose interactions produce every stable pattern we observe. This answer is simple, but it is not simplistic. Nothing essential has been left out. Objects, forces, space, time, and change all find their place within this description. What once appeared as separate ingredients turn out to be aspects of a single framework operating everywhere. Fields provide continuity. They exist whether or not particles are present, and they define what space itself can support. Energy belongs to their states, not to objects moving independently. Information records which distinctions are real and which outcomes have occurred. Constraints ensure that none of this behaves arbitrarily. Particles no longer need to be treated as fundamental building blocks. They are events, patterns, or excitations that appear when fields take on specific configurations. Their properties are not intrinsic possessions. They are expressions of the rules governing the fields they arise from. Solidity, which seemed so basic at the beginning, is now fully accounted for. It emerges from stable configurations enforced by constraint, multiplied across scale, and reinforced by interaction. Nothing solid lies beneath it. Structure does the work instead. This framework also explains why the universe is intelligible. Behavior repeats because the rules are uniform. Prediction works because constraints do not fluctuate. Complexity arises not from exception, but from accumulation. The same principles apply whether the system is simple or vast. Importantly, this answer does not depend on interpretation or philosophical preference. It follows directly from what experiments demand and what explanations must provide. Each step replaced an assumption with a mechanism, and each replacement narrowed the picture rather than expanding it. What remains is a world that is quieter than intuition expected, but far more secure. Nothing hides behind the rules, nothing arbitrary slips through. Reality is not propped up by substance, intention, or mystery. It is sustained by structure that holds everywhere and always. Stated plainly, reality is made of fields obeying constraints that shape energy, encode information, and produce stable patterns through interaction. That description is not provisional. It is the simplest form that survives every test placed before it. With that answer in place, nothing essential is missing. The universe stands fully described at its foundation, and what follows from it does so by necessity rather than speculation. With the foundation now stated plainly, its consequences settle into place. If reality is built from fields governed by constraint, then nothing exists in isolation. Every object, event, and process is an expression of shared structure acting consistently across space and time. This means that change is never arbitrary. When something happens, it happens because the rules allow it, and because conditions require it. Novelty appears, but it appears lawfully. The universe does not invent outcomes moment by moment. It selects from what is already permitted. It also means that emptiness is not fragile. Regions without matter are not gaps in reality. They are regions where fields remain present and active, maintaining continuity and enforcing the same constraints found everywhere else. Nothing fundamental drops away where particles are absent. From this perspective, complexity becomes understandable. Rich behavior does not require new ingredients. It requires repetition, accumulation, and interaction within a stable framework. The same rules that govern a single electron also govern galaxies, because no separate layer of reality is introduced at larger scales. This picture also carries a quiet reassurance. Stability is not accidental. Predictability is not temporary. The universe does not rely on balance that could easily fail. It is held together by constraints that do not weaken with time or distance. What works here works everywhere. Human experience fits cleanly within this structure. Thought, memory, and perception are physical processes carried by fields, energy, and information like everything else. They do not sit outside reality. They participate in it fully, obeying the same rules without exception. Nothing mystical is required to account for meaning or order. Meaning arises when stable patterns persist and interact. Order appears when constraints enforce consistency. Both are natural outcomes of the same framework that produces solidity, motion, and time. When asked what reality is made of, quantum physics does not point to a hidden substance or an unreachable layer. It points to structure that is already doing all the work. Fields exist, constraints govern them, patterns emerge, stability follows. From this, one conclusion holds firmly. Reality is not something added together from pieces. It is something maintained by rules that apply everywhere at once. What exists does so because it is allowed, and what endures does so because it is protected by constraint. With that understanding, the picture closes cleanly. There is no missing ingredient waiting to be discovered beneath the foundation. The universe stands on structure alone, coherent, governed, and sufficient, and everything that appears within it follows from that fact without remainder. From the foundation already established, one consequence becomes unavoidable. If reality is governed by fields, constraints, and permitted patterns, then what we call things cannot be primary. They arrive later as outcomes of ongoing activity rather than as basic units. In everyday life, objects feel self-contained. A cup appears to sit on a table as a complete item, carrying its identity with it from moment to moment. This impression is practical and reliable, but it hides what is actually doing the work. The cup persists not because it is a static lump of substance, but because countless processes continue to hold it in a stable configuration. At the deepest level, nothing simply is. Everything continues. Fields maintain patterns. Energy circulates within limits. Information is preserved through constraint. What looks like an object is a region where these processes reinforce one another so consistently that change becomes difficult. This is why stability requires activity rather than rest. Atoms remain bound because field configurations continuously satisfy their constraints. Solids retain shape because interactions are constantly renewed across their structure. If these processes stopped, the object would not quietly remain. It would cease to exist in that form. Seeing objects as processes resolves a long-standing tension. It explains how identity can persist, even though material content changes. The atoms in your body are replaced over time, yet the pattern that defines you remains. Continuity belongs to organization, not to ingredients. This perspective also explains why objects respond rather than resist passively. When a surface supports weight, it is not because it is inert. It is because active constraints redistribute energy and enforce limits. What feels like firmness is coordinated response, not stubborn stillness. Nothing in this view diminishes reality. Processes are not weaker than things. They are more fundamental. They are what fields naturally do under constraint. Objects appear where those processes settle into long-lived arrangements. Importantly, this does not make the world unstable. Quite the opposite. Processes governed by strict rules are dependable. They repeat, they hold, their outcomes can be trusted precisely because they are continuously maintained. By understanding things as secondary to processes, the picture simplifies. There is no need to imagine reality as assembled from tiny blocks. What exists is ongoing structure, sustained moment by fields behaving lawfully. From here, identity no longer depends on substance, and persistence no longer requires permanence of material. What matters is that the process continues under the same constraints. Where it does, the object exists. Where it does not, it changes. This redefinition is not philosophical decoration. It is a direct consequence of the framework already in place. Reality is active at every level, and what we call things are the stable faces of that activity, maintained by processes that do not stop. With objects understood as sustained processes, another consequence becomes clear. Nothing in reality carries its properties in isolation. What something is cannot be separated from how it interacts, and what constrains it. Properties arise through relationships rather than residing inside things. In everyday experience, it feels natural to assign traits directly to objects. A particle has a position, an object has a mass, a system has a state. These descriptions work because relationships are stable enough to fade from view. Yet beneath that stability, every property is defined through interaction with something else. Position exists only relative to a reference. Energy appears only through change or comparison. Even charge and mass reveal themselves through how systems influence one another. Remove the relationships, and the properties lose meaning. Nothing remains to anchor them. Quantum physics makes this explicit. A system does not carry a complete description on its own. Its allowed states depend on boundaries, surrounding fields, and prior interactions. What can occur is shaped by context, not by an internal list of attributes. This does not weaken reality, it strengthens it. Relational properties are not vague or negotiable. They are governed by strict rules that apply everywhere. Because relationships are constrained, outcomes are consistent. The same conditions always produce the same responses. Entanglement provides the clearest example. Two systems can share properties that belong to neither one alone. The description applies only to the pair as a whole. Separation in space does not dissolve this structure, because the relationship itself is what the rules preserve. At larger scales, relational structure becomes layered. Objects interact with environments. Environments constrain behavior. History matters because past interactions shape present possibilities. Identity emerges from continuity of relationship rather than isolation. This explains why isolation is an approximation. Systems appear independent only when interactions with their surroundings dominate and wash out delicate correlations. Independence is produced. It is not fundamental. By recognizing relations as primary, the framework simplifies again. There is no need to imagine hidden cores carrying intrinsic traits. What exists are systems embedded in networks of constraint that define what they can do. Stability follows naturally from this view. When relationships are maintained, properties persist. When relationships change, properties change with them. Nothing mysterious is required to explain either outcome. Reality, at its base, is not a collection of self-contained entities. It is an organized web of interactions governed by rules that never loosen. What something is arises from how it is related, and because those relations are constrained, the world remains reliable without exception. Once reality is understood as relational and process-based, identity takes on a clearer form. Something can remain the same without being made of the same material, because sameness no longer depends on substance. It depends on continuity of pattern under constraint. In everyday terms, identity feels tied to composition. A thing is what it is because it is made of particular parts. Yet even at human scales, this picture quietly fails. The material content of living systems is constantly replaced. Molecules enter and leave. Atoms are exchanged with the environment. Still, the system remains identifiable. Quantum physics shows that this is not an exception. It is the rule. Identity is preserved when a configuration continues to satisfy the same constraints over time. What matters is not which constituents are present at a given moment, but whether the organizing pattern persists. Fields make this possible. They do not care which specific excitations occupy them, only whether allowed configurations are maintained. As long as the governing rules are satisfied, the system remains what it is. Replacement does not threaten identity, it enables it. This explains why particles of the same type are indistinguishable. One electron is not marked as different From another, because identity does not reside in hidden substance. It resides in the field configuration that defines what an electron is. Any excitation that fits that pattern is fully equivalent. At larger scales, the same logic applies. A river remains the same river even though no single molecule of water stays. A flame persists even as fuel is consumed and replaced. What endures is the process held within bounds, not the matter passing through it. This continuity is not vague, it is enforced. Constraints ensure that only certain transformations are allowed without disrupting the pattern. As long as changes remain within those limits, identity holds. When they do not, the system becomes something else. Seeing identity this way removes the need for hidden cause or essential substances. There is no inner material essence that must be preserved. There is only structure that must remain intact. Where structure holds, identity follows. This view also explains why identity can fail. When constraints are broken or reorganized beyond recovery, the pattern dissolves. The system does not slowly lose itself, it changes categorically. Identity ends because the conditions that maintained it no longer apply. Nothing about this is abstract. It is how reality actually maintains continuity. From particles to people, persistence is achieved through ongoing compliance with rule, not through frozen material sameness. With identity grounded in pattern rather than substance, the framework remains internally consistent. Change becomes compatible with continuity. Replacement no longer threatens existence. What something is depends on what continues to hold, and when that holds, identity remains secure. Change often feels like the opposite of stability. If something is changing, it seems as though it should be becoming less reliable, less defined, or closer to falling apart. Within the framework already established, the opposite is true. Stability depends on change proceeding, within constraint, not on change being absent. At the fundamental level, fields are never frozen. They evolve continuously. Energy redistributes. Interactions occur. These dynamics do not undermine structure because they are limited by rules that remain fixed. What is stable is not a static arrangement, but a regulated range of motion. This is why motion does not dissolve objects. Atoms vibrate, molecules shift, energy flows through every material system. None of this causes collapse because the allowed variations are bounded. The system can move without leaving the space of permitted configurations. Change becomes threatening only when it exceeds those bounds. As long as transformations remain compatible with the governing constraints, the overall pattern persists. Stability is not the absence of activity, it is the persistence of rule following activity. This perspective clarifies why systems can adapt without losing identity. A solid can warm, expand slightly and return to its original form. A living organism can grow, repair, and reorganize. These changes are not tolerated accidents. They are expected behaviors within the allowed range. Quantum physics enforces this logic at the smallest scales. Transitions between states occur discreetly and lawfully. Certain changes are allowed, others are forbidden outright. This selectivity prevents drift into undefined behavior. Change happens, but only in sanctioned ways. At larger scales, the same principle explains resilience. Structures endure stress because internal processes redistribute energy and restore balance. What feels like resistance is coordinated adjustment. The system changes in order to remain the same. This removes a deep-seated fear built into intuition. Order does not sit on the edge of collapse, waiting for disturbance. It is maintained through continuous response. The universe is not stable despite change. It is stable because change is governed. Seen clearly, breakdown is not gradual erosion of order. It is a categorical shift. When constraints can no longer be satisfied, the system transitions into a different stable configuration or ceases to exist in its prior form. Nothing ambiguous occurs in between. This understanding also explains why new structures can arise. When conditions change enough to permit different configurations, stability reappears in a new form. Change does not destroy order, it relocates it. By placing change inside the framework of constraint, stability becomes robust rather than fragile. Systems endure not by resisting transformation, but by channeling it. What remains is a world in constant motion that nonetheless holds together without effort. At this point, change is no longer the enemy of structure. It is the means by which structure sustains itself. Stability persists because the rules governing transformation never relax, and as long as those rules hold, reality remains coherent through every shift it undergoes. As stability and change fall into place, one more consequence becomes clear. The laws governing reality do not alter as systems grow larger or smaller, yet behavior clearly does. This difference does not signal a shift in rules. It reflects how the same rules operate when applied across vastly different scales. At small scales, individual interactions matter. A single exchange of energy can alter outcomes. Possibilities remain visible because constraints act on relatively few components at a time. Variability is allowed to express itself openly. As scale increases, repetition takes over. Interactions multiply. Constraints act simultaneously on enormous numbers of components. What was once flexible becomes tightly regulated. The rules have not changed, but their combined effect becomes overwhelming. This is why quantum behavior feels delicate while classical behavior feels rigid. At small scales, alternatives remain available because constraints have not yet compounded. At large scales, alternatives still exist in principle, but they are suppressed so thoroughly that they never appear. The same framework governs both regimes. Fields behave the same way. Conservation laws remain intact. Information is still redistributed through interaction. The difference lies only in how many times these processes occur at once. This explains why large objects do not display wave-like behavior in daily life. The patterns that allow such behavior are drowned out by constant interaction with the environment. Scale locks systems into narrow channels of behavior, even though the underlying possibilities never vanish. Importantly, no boundary separates these regimes. There is no point at which quantum rules turn off and classical rules switch on. Behavior shifts smoothly as constraints accumulate. Predictability emerges gradually, not abruptly. This continuity protects coherence. Physics does not require special explanations for different sizes of things. It requires only an understanding of how scale amplifies constraint. The same principles apply everywhere, producing different appearances without contradiction. At cosmic scales, the pattern holds. Stars, galaxies, and clusters follow the same rules as particles and atoms. Their behavior appears orderly because interactions are vast and persistent. Stability is enforced by accumulation rather than by new law. Seeing scale this way removes a common confusion. The universe is not layered into separate domains with separate rules. It is unified. Differences arise from quantity, not from principle. With this understanding, behavior at every scale becomes intelligible. The rules remain fixed. Their effects intensify with scale. What changes is not what governs reality, but how completely governance asserts itself. Reality behaves differently across scales because constraint compounds, not because the foundation shifts. The universe remains one coherent system, applying the same structure everywhere and allowing scale alone to determine how firmly outcomes are enforced. By this stage, the role of physical laws can be stated precisely. They are not instructions issued to the universe from outside. They are descriptions of what cannot vary given the structure already in place. It is tempting to imagine laws as rules being obeyed, as though reality could choose otherwise but does not. That picture suggests an external authority or hidden mechanism enforcing compliance. Quantum physics removes the need for that image entirely. Fields do not consult laws before behaving, they simply evolve according to their nature. Constraints are not imposed afterward. They are built into what the fields are. What appears as a law is a summary of what never changes when those fields evolve. This is why laws are discovered rather than invented. They are not arbitrary conventions. They are regularities that remain visible no matter how systems are probed. When experiments are refined, laws do not soften, they sharpen. Conservation laws illustrate this clearly. Energy is conserved not because something ensures it must be, but because the structure of fields does not permit alternatives. There is no hidden store where energy could disappear to. The framework itself forbids that outcome. The same applies to other laws. Symmetries reflect invariances in structure. Limits reflect boundaries in what configurations are allowed. Nothing enforces these rules from outside reality. They arise because reality cannot behave differently without ceasing to be what it is. This reframing removes a lingering mystery. There is no separate layer where laws reside. There is no deeper rulebook behind the universe. What we call laws are stable features of the framework already described. This also explains why laws are universal. They apply everywhere because the structure they describe exists everywhere. There is no region of space where fields behave differently because nothing distinguishes one region from another at the fundamental level. Importantly, this does not make laws fragile. It makes them unavoidable. They persist not because they are maintained, but because there is nothing else for reality to do. Violation is not resisted. It is impossible. By understanding laws as expressions of constraint rather than commands, coherence is restored fully. The universe is not following instructions. It is unfolding according to what it is. At this point, physics reaches a kind of closure. The behavior of reality no longer needs justification beyond structure. Laws are not added explanations. They are names for the invariances that remain when everything else is allowed to change. Reality holds together because its structure does not permit inconsistency. What we call physical law is simply the stable outline of that structure, visible wherever reality is allowed to act. With laws understood as expressions of structure rather than commands, predictability takes on its proper meaning. The universe behaves reliably, yet it is not pre-written in detail. Outcomes are constrained without being pre-selected. Predictability arises because the rules governing fields do not fluctuate. Given the same conditions, the same ranges of behavior appear every time. Patterns repeat, distributions stabilize, large-scale outcomes become dependable. This reliability is what allows science, engineering, and everyday expectation to work at all. At the same time, the framework never specifies a single future in advance. It specifies boundaries. Within those boundaries, multiple outcomes remain possible until interaction resolves them. The universe does not consult a script that dictates what must happen next. It follows rules that define what may happen. This balance explains why surprise and regularity coexist. A specific quantum event may occur here rather than there, now rather than later, yet the overall structure remains unchanged. The unpredictability of individual outcomes does not weaken the predictability of patterns. It is contained within it. At larger scales, this openness narrows. Interactions multiply. Constraints accumulate. The range of allowed behavior collapses toward a single path that dominates all others. The future becomes effectively fixed, not because it was written in advance, but because alternatives have been ruled out by scale. This distinction matters. A scripted universe would leave no room for contingency. Everything would be determined regardless of condition. A constrained universe produces order without eliminating possibility. What happens depends on how conditions unfold, even though the rules never change. This is why choice, variation, and novelty are compatible with physical law. New configurations arise when conditions permit them. They are not violations. They are lawful expressions of structure responding to circumstance. Nothing in this picture is fragile. Predictability does not rest on delicate balance. It rests on constraint that applies everywhere. Openness does not threaten order. It operates inside it. By separating governance from predestination, the universe becomes intelligible without becoming rigid. The same framework explains why we can rely on the world and why it can still surprise us. At this stage, predictability is no longer confused with inevitability. Reality is stable because its rules hold. It remains open because those rules define ranges, not scripts. The universe is reliable without being rehearsed, and lawful without being locked into a single outcome. With predictability grounded in constraint rather than scripting, one final intuition dissolves. The universe does not require a binding agent to keep it intact. Nothing is gluing reality together from behind the scenes. Coherence does not depend on a supporting substance or an underlying scaffold. It is natural to imagine that order must be maintained by something acting continuously to prevent collapse. In everyday life, structures fall apart when supports are removed. From that experience, it feels reasonable to assume that reality itself must rest on something similar. The framework developed so far shows why this is unnecessary. Fields do not drift because there is nowhere for them to drift to. Their behavior is already confined by what they are allowed to be. Constraints do not need reinforcement. They are not applied moment by moment. They are built into the structure that defines every possible state. This is why reality does not unravel. There is no tendency toward disorder that must be resisted. There is only permitted change occurring within fixed limits. As long as those limits exist, coherence follows automatically. Even interactions that seem disruptive obey this logic. Collisions, decays, and transformations rearrange patterns, but they do not threaten the framework itself. The rules governing redistribution remain intact. Nothing escapes them. Nothing bypasses them. The absence of a binding agent also explains why the universe scales without strain. There is no central point that must coordinate distant regions. There is no background substance that could thin or tear. The same structure exists everywhere at once because it is not carried or transmitted. It simply is. This removes the need for metaphors involving fabric, glue, or support beams. Space is not held together by tension. Reality does not sit inside anything else. What holds is not an extra ingredient. It is the impossibility of behaving otherwise. Seen clearly, coherence is not maintained. It is inherent. The universe remains ordered because its fundamental description does not permit disordered existence at the same level. Disorder appears only within allowed rearrangements, never as a breakdown of structure itself. This understanding also clarifies why stability feels effortless. Nothing is working to keep reality intact. Nothing could fail in a way that would cause everything to come apart. What exists persists because it is defined by rules that do not decay. By letting go of the need for a cosmic support, the picture becomes simpler and stronger. Reality stands without reinforcement, without maintenance, and without hidden machinery. It holds because its structure allows only holding. At this stage, coherence is no longer something to explain further. It is the default outcome of a framework built entirely from constraint. Nothing needs to bind reality together, because there is nothing it could come apart from. With coherence no longer requiring support, the idea of a deeper hidden layer loses its purpose. The framework does not point downward toward another substance waiting to be discovered. It closes on itself in a way that is complete rather than provisional. Many explanations feel unfinished because they stop at something unexplained. A force is reduced to a mechanism. A mechanism is reduced to a component. The search continues because each layer depends on something beneath it. The picture developed here does not behave that way. Fields, constraints, and structure do not lean on a further foundation. Fields are not made of something else. They are the medium in which made of stops applying. Constraints are not enforced by a deeper rule. They are the limits that define what counts as a possible state at all. Structure does not arise from hidden machinery. It is what remains when everything arbitrary has been removed. This does not mean physics has reached the end of discovery. It means the kind of question changes. Refinement replaces reduction. Relationships become clearer. Descriptions become more precise. What does not happen is the revelation of a new layer that explains the old one away. This is why attempts to imagine reality as resting on smaller and smaller pieces eventually stall. The framework does not resolve into particles beneath particles. It resolves into rules that do not fragment. Looking deeper reveals tighter constraint, not additional substance. The absence of a hidden layer also explains why the theory remains stable under extension. New phenomena are incorporated by adjusting how fields interact or how constraints apply, not by discarding the foundation. The core picture survives because nothing beneath it needs replacement. Importantly, this closure is not philosophical. It is structural. Every element introduced earlier earned its place by necessity. Remove any one of them, and the explanation fails. Add another beneath them, and it does no explanatory work. Nothing remains for it to support. This is why the picture feels quiet rather than dramatic. There is no final reveal waiting below the surface. What exists is already doing all the work required. The universe does not hide its foundation. It expresses it continuously. At this stage, depth no longer means descent. It means clarity. Understanding improves by seeing how pieces relate, not by uncovering a new stratum. The foundation remains the same no matter how closely it is examined. With this realization, the framework achieves finality of a specific kind. It does not claim to explain everything that can happen. It claims to explain everything that must hold for anything to happen at all. Nothing sits beneath that requirement. Reality, as described here, is not layered endlessly downward. It is bounded by structure. Fields exist. Constraints govern them. Patterns emerge. That is the base, and there is no further floor below it, waiting to be revealed. With coherence no longer requiring support, the idea of a deeper hidden layer loses its purpose. The framework does not point downward toward another substance waiting to be discovered. It closes on itself in a way that is complete rather than provisional. Many explanations feel unfinished because they stop at something unexplained. A force is reduced to a mechanism. A mechanism is reduced to a component. The search continues because each layer depends on something beneath it. The picture developed here does not behave that way. Fields, constraints, and structure do not lean on a further foundation. Fields are not made of something else. They are the medium in which made of stops applying. Constraints are not enforced by a deeper rule. They are the limits that define what counts as a possible state at all. Structure does not arise from hidden machinery. It is what remains when everything arbitrary has been removed. This does not mean physics has reached the end of discovery. It means the kind of question changes. Refinement replaces reduction. Relationships become clearer. Descriptions become more precise. What does not happen is the revelation of a new layer that explains the old one away. This is why attempts to imagine reality as resting on smaller and smaller pieces eventually stall. The framework does not resolve into particles beneath particles. It resolves into rules that do not fragment. Looking deeper reveals tighter constraint, not additional substance. The absence of a hidden layer also explains why the theory remains stable under extension. New phenomena are incorporated by adjusting how fields interact or how constraints apply, not by discarding the foundation. The core picture survives because nothing beneath it needs replacement. Importantly, this closure is not philosophical, it is structural. Every element introduced earlier earned its place by necessity. Remove any one of them, and the explanation fails. Add another beneath them, and it does no explanatory work. Nothing remains for it to support. This is why the picture feels quiet rather than dramatic. There is no final reveal waiting below the surface. What exists is already doing all the work required. The universe does not hide its foundation, it expresses it continuously. At this stage, depth no longer means descent, it means clarity. Understanding improves by seeing how pieces relate, not by uncovering a new stratum. The foundation remains the same no matter how closely it is examined. With this realization, the framework achieves finality of a specific kind. It does not claim to explain everything that can happen. It claims to explain everything that must hold for anything to happen at all. Nothing sits beneath that requirement. Reality, as described here, is not layered endlessly downward. It is bounded by structure. Fields exist. Constraints govern them. Patterns emerge. That is the base, and there is no further floor below it, waiting to be revealed. With the foundation complete and no hidden layer left beneath it, the final consequence concerns where we stand. Living systems are not observers placed outside the structure of reality. They are expressions of that structure, operating under the same constraints and participating in the same processes. From this view, experience is not separate from physics. Sensation, thought, memory, and decision arise through lawful interactions among fields, energy, and information. Nothing special has to be added to make experience possible. It emerges because the framework already supports stable patterns capable of storing and transforming information over time. This places human life fully inside the universe, rather than at its edge. There is no divide between what the world is made of and what we are made of. The same rules that govern atoms and stars govern bodies and brains. Continuity is preserved without reduction or dismissal. Meaning, then, does not require exemption from physical law. It arises when patterns persist, interact, and matter to one another within constraint. Care, intention, and understanding are not violations of structure. They are structured phenomena, made possible because stability and openness coexist. This also reframes responsibility. Actions are not free because they escape causality. They are free because the framework allows multiple futures within boundary. Choice exists, where constraints permit divergence and where information can influence outcomes. That permission is real and physically grounded. Nothing about this diminishes value. If anything, it secures it. What endures does so because it is supported by the same rules that hold the universe together. Fragility exists, but it exists within a structure that allows renewal, adaptation, and continuity. Living inside a structured universe means that understanding deepens rather than disenchants. Explanation does not strip meaning away. It shows how meaning can persist without mystery or exception. The world remains worthy of attention precisely because it is coherent. This perspective also invites a particular calm. The universe does not teeter on the edge of collapse. It does not require constant correction. What exists is allowed to exist by rules that do not waver. Participation in such a universe does not require vigilance, it requires alignment. At the end of this progression, nothing needs to be added and nothing needs to be removed. Reality is not a puzzle missing its final piece. It is a structure already complete, expressing itself through countless stable and changing forms. To ask what reality is made of is to ask what must hold for anything to appear at all. The answer is now clear. Reality is made of structure that governs itself, supports complexity, and allows experience to arise without contradiction. Reality holds because its structure allows nothing else, and everything that appears does so within that allowance.